Thank you so much for that wonderful introduction. Very excited to be here today along with my panelists. Again, I am Abigail Sveden. I am a research genetic counselor at Boston Children's Hospital, and I focus on translational neuroscience, and have, through that work and some of my past experience, gained very strong passion in variants of uncertain significance, or VUS, as we'll be referring to them today. But could not do this talk without my wonderful panelists, who I will allow to introduce themselves.
Thank you, Abigail. My name is Dustin Baldridge. I'm an assistant professor at Washington University in St. Louis. I run a research laboratory where we study variants of uncertain significance in the lab for a handful of genes. We try to provide functional experimental data to help classify them as either benign or pathogenic, as we'll get into. I'm also privileged to have a role with the Undiagnosed Diseases Network, where I help with our Model Organism Screening Center. Delighted to be here as well.
My name is Chris Gurnett. I'm a professor of neurology, also at Washington University in St. Louis. I am the co-director of our Intellectual and Developmental Disabilities Research Center and do a lot of work in the area of neurogenetics and see patients with epilepsy.
Hi, I'm Michele Herndon, and I am the program director for patient navigation at the Undiagnosed Diseases Network Foundation. Before that, I worked for 18 years at the Pediatric Hospital at Washington University in St. Louis. And in addition, I was a pediatric nurse there, but in addition, I am also the mother to 3 children. My oldest son, Michele, had an extremely rare disease that was discovered after 7 years being undiagnosed through the Undiagnosed Diseases Network. So I am a fangirl of people who work with model organisms because the Baylor site of the UDN used fruit flies to discover the mutation that was causing my son's disease. So I am a huge supporter of model organism work. I have some experience with variants of uncertain significance, and I'm excited to be here to share with you.
Wonderful. Thank you all so much. So I know that people in this room may have varying levels of knowledge about VUS. So just to provide a little bit of background information, I wanted to fill you in. It may or may not be new information to you. So variants of uncertain significance, I will get my slide up here, are ways that laboratories can decide, is a genetic variant, which all of us have genetic variation, but not all of it is something that could impact our health. So there are these different classifications, which we have this sliding scale, as you can see, from the left being benign and the right being called pathogenic, that we use to decide, is this likely or unlikely to impact our health? So at the bottom arrow that's green, you can see it says evidence of being benign. So this is information that tells us this genetic change is not likely to impact our health. This information might be that somebody who doesn't have a condition associated with their health has had this variant before. And at the top end where it says evidence of pathogenicity and it's red, this would be information that makes us think, yeah, I think this is pretty likely to be really relevant for health and could impact somebody's health. So with the least or the most amount of benign information, it would be classified as benign. If there's some benign information, but not as much as the full benign status, it would be likely benign. On the other end, similar for pathogenic, if there's a lot of evidence of impacting health, it's pathogenic. And if there's just a little bit less, it might be likely pathogenic. But in the middle, if you either don't have evidence either way, or there's a little bit of evidence that would make us think both, it'll be classified as a VUS, which can create a lot of challenges for the patients, the caregivers, as well as researchers and physicians. And there are also, you might not have seen benign or likely benign on reports before, because the VUS, likely pathogenic, and pathogenic are what are typically reported out by labs. Some laboratories, which we'll get into later, might not even report VUS depending on the disease type as well. It also might be helpful to know that there are different reasons that a variant might be classified as a VUS in addition to the types of evidence that we use to classify them. One is that it is a gene that is known to be associated with the condition, but the variant's properties make it uncertain. Alternatively, it could be a gene that we don't have much information about. We don't know if it's associated with the condition yet, but the variant might have properties that make it very convincing. They might have a lot of pathogenic evidence. So it can be important when you're thinking about your journey and the types of next steps that you need to take to know the difference between these two. And with these genes that have limited information, we're going to refer to them today as genes of uncertain significance, or GUS. So we have our VUS and our GUS. And it additionally may be helpful to know that in addition to the classification that's given out by a laboratory, one of these different options, there are interpretations that are given by healthcare providers who order and then return results for these tests. So if you have, for example, a geneticist who has a lot of information and they have a background in interpreting variants, they really might be able to give you a lot of information about whether this VUS might be something that could eventually be thought to impact health or might not be. But sometimes there are providers who haven't had this training or are in specialties outside of genetics who may not be able to provide this information and just take the test at face value. There is hope for the future for providers who may not have this specific training. We know that not everybody is able to access a genetics provider. So in the future, there will be new classification categories, which I've shown here, that, as you can see, add in categories on either side of VUS. One which is a VUS which is leaning pathogenic, and a VUS that is leaning benign. So these might help providers to know if this VUS might eventually be classified as pathogenic or likely pathogenic, or if it's more likely to eventually be classified as benign. Of course, these are not classifications that are impossible to move one way or the other, but it can help with interpretation and could also help you as a patient or patient advocacy group to know which variants are most worth the pursuit of reclassification. And this would also be a proposed way of reporting from laboratories where they might not, or might, I think this is still a topic of discussion, report these VUS that are leaning benign or not quite at the leaning pathogenic stage. But with that, I'm going to join my panelists so that we can converse together. All right, well, now is the exciting part because you get to stop learning from me and get to start learning from them. So I wanted to start with, I talked about VUS can be reported by a laboratory. Sometimes they're not, sometimes it's different disease types. When are the VUS actually reported by the lab? And are they always shared with patients? Are there some that won't be shared?
Yeah, this is a great question. I guess the whole topic of VUS is so complicated. It's why we're having this, the panel. You certainly know that there are providers that have more experience in interpreting the variants, and genetics is complicated, and not everyone has the knowledge to return that information. Genetic counselors are great resources. Geneticists are great resources. Some neurologists know a lot, some know a little. And I think there is a concern that there are a lot of VUSs that are tucked in the back of the medical record and never returned to a family because there's a belief that they're not related at all, which may be appropriate, but those still may be hidden in a medical record and never to be looked at again. And that's not the right approach. The data can change over time, and so having knowledge that the interpretation may change as more information is known is really important.
I think I can give a personal example just of my son and the VUS that did come back on his report, just if it helps you to kind of understand maybe why they get classified VUS sometimes. This was back in 2013, and we were told they were going to do this really newfangled thing called a whole exome sequencing. And back then it was like not everybody was getting it. And when it did come back, there was really nothing, but there was a variant found in a gene, But they just said, we're not sure because there is a disease associated with this gene, but it's totally different. Like babies die before they're 1. My son was 13. Just it didn't match at all. And so they were like, we think this is unknown. And just at that point, I didn't know enough about genetic testing. We just kind of were like, okay, put the paper in the drawer. And it took quite a while before we got answers, but that was our experience with the VUS. And at the time, it was, frankly, for those of you who were undiagnosed for a long time, it was just yet another test that came back that told us nothing. And so it's frustrating to not get answers, of course.
Absolutely. I imagine that was incredibly frustrating. And I'm curious, you said that you put the report in a drawer for a while. And was there something specific that made you want to revisit those results and kind of spurred this reinterest and eventually led you to diagnosis?
Well, unfortunately for us, it was time and medical decline for my son. So his symptoms got worse, and he had an amazing pediatric neurologist, a colleague of these two here. And I have to just mention too that this is like a crazy moment for me because, Dr. Gurnett cared for my son one weekend because his neurologist, was gone and she was on call. Dr. Baldridge was a resident who took care of my son. And if you had told me a decade later I'd be on a panel talking about this with them, I would have never believed you, because back then I was a pediatric nurse and a mom who knew nothing about genetics, to be honest. It's not really much taught in nursing school. So I'm so privileged to be here with you too. But basically my son got worse and technology improved. And we sought second opinions, third opinions that were recommended to us at not shabby places, right? Children's of Philadelphia, University of Alabama, Birmingham, Washington University in St. Louis. Everyone was saying, this is a genetic disease that we just don't know about yet. And so ultimately, my son went through the Undiagnosed Diseases Network, which I'm happy to talk more about. And they took his whole exome, but then combined it with my husband and mine and did whole genome sequencing. And were able to say, that VUS that we found 10 years ago, we actually think this is it. And that's when the fruit flies came into play, and they ultimately made the discovery.
Wonderful to hear a little bit more about your story. And when you're talking about eventually went from exome and then you pursued genome, makes me think about, there are different tests and different factors that can make somebody more likely to receive a VUS or more likely to receive, any sort of result that's returned at all. I'd love to hear from both of you a little bit about your experience and knowledge of that.
Sure, yeah, I'd like to weigh in here a little bit. So there's lots of different criteria that we can use in the lab to decide if a variant is considered pathogenic or VUS or benign, as Abigail was alluding to earlier. One of these criteria that I want to emphasize is the inheritance pattern of the variant. So if it's a single variant and just one copy of the gene, and it's brand new in the child, we call that de novo. That would give a variant a lot of points in terms of towards pathogenic. Conversely, if it's a single variant and a copy of a gene and it's inherited from a parent who's unaffected, that would give it points towards being benign. So inheritance pattern is a really important piece of data that can be used to classify variant as VUS, from a VUS to be pathogenic or benign. So that's why some genetics providers or whoever's ordering the genetic testing will come back if just the child was tested and say, it would really help a lot if we could test the parents for this. And I'd like to share that my children are both adopted, and so I fully recognize that not every situation can you actually obtain parental testing, and so that further complicates the picture. But that's just one example. So there's others that might come up in the course of our conversation, but I think I'll toss it to my colleague.
I also worry a lot about health equity in genetic testing. We know that people from underrepresented populations don't have as large of a publicly accessible, controlled, healthy individual data set to screen against. And so we find a lot more VUSs in people from underrepresented populations. And that is a huge problem, and that we are working to fix by populating those data sets with larger cohorts from people from all over the world.
Mm-hmm.
I just mention one more, if that's okay. So I'm thinking about some of the work that we do in our own laboratory. for particular genes. Some genes are associated with conditions that are super specific, that somebody would recognize as being a genetic syndrome. So the one that we study, for example, involves like midline facial abnormalities and an extra digit on your hand or foot. Like that's kind of hard to miss. And so that's going to be something that goes together and is probably genetic. And so then if we come back with the variant in the gene that we study, okay, that makes sense, and that would give it some more points in terms of the specificity of the phenotype for being more likely to be pathogenic. And then there's other conditions that we might test for genetic disorders like epilepsy or maybe autism or intellectual disability. If any of those are in isolation, those are actually relatively common phenotypes. And so if we get back a variant in a gene that may be associated only with seizures or only with intellectual disability or only with autism, it's really nonspecific, and so the odds of that happening by chance are greater, and so it's harder then to use that information in terms of reclassifying the variant. So anyway, there's many other factors that we consider, like what Dr. Gurnett was referring to for population allele frequencies. Just in the general population, is this variant found with certain frequency or not? That's important to take into account. And then the last point I wanted to make too is that our information and understanding of these things changes, right? So I was talking about specificity of the gene and the phenotype, and I heard Michele talking about, she was initially told that this doesn't go with her child's condition because it doesn't match. Well, that's what we knew at the time, and our information has changed to say, oh, actually, there's two conditions that go with this gene.
Right.
So that's really important to consider as well, is that what the information we are given today is the best information we have at the time, and information changes over time.
Absolutely, yes. I've definitely had that experience in my own research as well, sometimes I do analysis of exomes and genomes for research, and I found at times that there are variants that, as I've discussed during my brief introduction, seem like they might be causative of disease, but that disease doesn't seem to match what we're seeing in the patient. That phenotypic specificity isn't there. But in waiting sometimes, or just searching in the right way, you can find the information that shares, both the variants and the gene that they're in really do match this patient's presentation. And sometimes it is unfortunate that diagnostic odyssey that you experienced. And I think it is really important, as well as we discussed a little bit during the introduction, and as Chris mentioned, to have a provider who really has that understanding and is able to interpret both the phenotype and has the genetics background. And Michele, you talked a bit about, kind of getting into the UDN and getting that genome. What else can patients do to advocate for the most likely chance of getting a certain result and to have anything come back at all?
Right. Well, I think you mentioned, the provider that you're working with is key. Are they someone who orders genetic testing a lot? Is this something that's in their wheelhouse? And if it's not, and this is the provider you have because of where you live, because of who you're able to see, then work together with that provider to maybe get questions answered before the test is ordered. Many of the genetic diagnostic companies have medical officers or genetic counselors on their teams who your provider or you can call up and say, these are my symptoms, this is what we're thinking, what tests should we order? And so, utilize that resource as much as you can. And then really, one thing I tell people is, you have a voice. You don't have to just say yes, okay to everything. Of course, you want to be polite and kind. But if a provider says, we're going to just do this panel, I suggest you question that and say, is there any reason why we wouldn't want to move right to whole exome sequencing? It seems like, this is where things are moving. Could we look into that? So you always want to ask that question and try and get, the most robust testing that's appropriate.
Thank you so much. Wonderful to hear your perspective, and thinking about perhaps even more robust, the furthest that a patient can go. We were discussing this a bit earlier, but I've heard from some patients that they're interested in not just getting the report, not just hearing from their provider, but actually receiving the raw data that was generated from their testing. I'd love to hear a bit of discussion between the three of you about what you think some of the benefits as well as the risks of that can be.
There's a lot of variants. Each of us have probably hundreds, if not thousands, of variants of uncertain significance in our genomes. I think knowledge is power. To have that data is great, and most companies will give that to you. Use it judiciously and find experts who can help either on a research, someone who's really interested in your condition and may have experience with interpreting large genomes or exomes would be helpful.
Completely agree. So one of the research projects that I help manage, we actively obtain the raw data from one of the testing companies with the patient's consent, of course, for participating in the research project. And that is super valuable for our research. We use that data both for the individual patient, but also we aggregate it together and help make diagnoses for other patients too. So I'm a big proponent of commercial diagnostic laboratories sharing the raw data, primarily for research purposes. I think for the individual family, I'm just trying to imagine, the specific use case. I think it's really important to think about what one would do with that data. Not just obtaining the data, but what is the plan to do with that data. And I just want to give a word of warning that there actually are somewhat unscrupulous or maybe unreliable resources available where one could upload your raw data and then maybe even get some scary information back. Not only would that information be scary, but it may actually be wrong. And so it's really important to think carefully about what's being done with the raw data and to make sure that it's being used with a reputable source. Who knows what would happen with the data that then gets uploaded to this, maybe shady website, right? So just to know that there are those things that are out there. On the other hand, there are very reputable places that people can bring their data to. I'll just mention one that I'm a big fan of that's run by the group in Seattle at University of Washington. It's called MyGene2, the number 2. And so they actually invite you to bring your raw data there, and it's a place to store it responsibly. You can actually write up a little bit of information about what the child's phenotype might be, what the clinical picture is, and then it gets put into this kind of research pipeline as well. So that's an example of a potentially good use of the raw data, in my opinion.
I'll also just make a plug for any research studies in this day and age should be giving you results back. And if you are looking at a research study and they're not willing to give you some information back, I would tell them that that's just not, it's really not appropriate. You're a partner in that research, and that's the respect for you is to get information back from the research. It may not happen as quickly as a clinical test, but there should be some responsibility, and most institutions are looking pretty critically at that. So,
yeah, that's so important. I was going to make sure you know the difference between are your genetics being tested as part of a research study or as a clinical study, and what they disseminate to you and how they disseminate it can be different. And so before you sign that consent form for the research study, make sure you ask that question: how will results be given to me? Will they be given to me in whole? Will there be any gatekeeping on what I receive and when I receive? So ask those questions. One thing, the thought of getting all the raw data kind of gives me heart palpitations, honestly. But getting the full report, I think, is really important. We've had some instances with patients that our navigators are working with at the Undiagnosed Diseases Network Foundation that their report on their genetic testing just said that they got a letter and paper that said negative. And we've encouraged them to call and say, I'd really like to receive the whole report. And I want to see what you listed as benign. I'd like to see the VUSs. And sometimes it's easy to get. Sometimes has to be some prodding. And again, kind and polite, using your voice. And we have examples, and I'm sure both of the clinicians up here as well, the researchers here would tell you they have examples as well of a VUS or something marked as benign that actually fits the phenotype of this patient, and the parents fight to find the researcher. They think, oh wow, yes, this does match, and now this child is receiving a therapy. Does that happen all the time? No, but it could, and you have a right to get that report and get your information. I do want to quickly say though too, if you are a patient or a caregiver, and you have a relationship with a provider who ordered your genetic testing, and you are not interested in Googling at 2 a.m. the variant, and you would rather trust that relationship you have with that provider to be on the lookout for when reanalysis should happen or other testing to do, that is fine too. I don't want anyone to think that they're being irresponsible if they're not, a weekend warrior on Google researching their child's VUS.
But I think the problem with the VUS, as you all know, is some patient advocacy groups, like, do you belong to that? Do you belong to that group? Or are you going to be eligible for clinical trials? And so I think there's a really important scientific need for the community to start addressing these through research.
Can I expand on that just a little bit? So, this problem is a big problem, in my opinion, the VUS problem, and it's growing dramatically, actually exponentially, because we're sequencing more people and finding more VUS, right? So there's a database called the ClinVar database where laboratories will deposit their interpretations of variants, and so you can just look there and see over time how many VUS have been reported. So currently there's more than 2 million VUS in the database, which just blows my mind. And 12 months ago, there were only 1 million VUS in the database. So we're literally growing by about 1 million a year. And so not necessarily each one of those, but approximately each one of those is a family that has a VUS that would like to have an answer about, does this variant impact my child's health or my own health or not? So I'm a huge proponent of research and more evidence to try to reclassify these variants. That's what's needed, more evidence. And so it'd be great if we could, test each of those variants one at a time. Does this variant cause disease or not? But 2 million is going to take us forever, right? So that's why my own laboratory and some other laboratories around the country are interested in developing these high throughput technologies. We use cell-based assays so we can test like 10,000 variants in the same experiment and get an answer for all of them at once. Even then we could do all the potential variants in a given gene, all the single base pair changes, and then give an answer ahead of time before the next patient walks in the door. So, it's a little maybe inside baseball here, but I'm a proponent of these high throughput cell-based studies to try to give more answers for more families more quickly.
I'll just also say that ClinGen is a huge win for the NIH and for federal, your tax dollars. The good news is that the companies that do sequencing have really bought into depositing their data into this repository, so it's all usable and it can help us to interpret and change the interpretation of a variant. So I am appreciative of the people who are behind ClinGen and that the companies have been very, very cooperative in sharing data.
Absolutely. It's certainly a resource that I go to very frequently and depend on heavily. And also thinking about all of these different things that you could do, which we'll get into a little bit more with research. We've talked a little bit about classifications changing. Can you talk a little bit about how or why that might happen?
Sure. It's okay if I kick this one off? Mm-hmm. So one thing, in thinking about the two buckets that Abigail talked about at the beginning of the presentation, I'm going to talk about genes of uncertain significance for a second, and just mention briefly that those can change and become genes of significance, meaning that now we know which diseases go with those genes. And so that can change a whole swath of variants from uncertain to now pathogenic. And then the other way is for these VUS to get reclassified. So there's this other repository I really like called GNOMAD, G-N-O-M-A-D, GNOMAD, and that is a collection of relatively healthy people that have all been sequenced, and it's this just aggregation allele frequency, meaning how often do we observe this variant in the general population? And if it's more common in the population, then we consider it probably not disease-causing, like I mentioned earlier. GNOMAD is now on version 4, so there's been 3 prior versions, and each time it gets to the new version, it gets bigger and bigger. So now I think they're up to 600 or 700,000 people, or maybe 800 that are in GNOMAD. And I understand version 5 is coming as well. And each time it gets bigger, it also includes more diverse populations as well. So like Dr. Gurnett was mentioning, it's important to understand, not just in one particular geographic area, ancestry, is this variant common or rare, but how about other ancestries as well? That can also be informative in terms of interpreting variants. So I'm a huge proponent of GNOMAD. So every time the new version of GNOMAD comes out, that's also an opportunity to reclassify variants as well. So, there's all kinds of exciting research ongoing that changes classifications, and then all kinds of growing resources. I just, I get so excited about this stuff. It's a really great time to be doing genetics research, and helping families as much as we can from this perspective.
And for people that are undiagnosed, we know that there are probably another 3,000, 4,000, 5,000 different genetic conditions where the gene has not yet definitively been linked to a disorder. And it can take years to collect those really rare patients. I think the other thing that's coming on the horizon is that some of these variants of uncertain significance, someone like Dustin will figure out that they actually do change the protein. So as we start sequencing people who are relatively healthy, we're going to find variants that are just mildly causing some of your memory problems or your cognition or differences in your muscle strength, and interpreting those is going to be really more challenging in the future too. So the quantitative data that the laboratory can get could be really helpful.
I'll just add, I think that, to get a variant to move from benign or VUS to pathogenic, we have to have some evidence. And what patient groups and patients and caregivers can do, one is contribute to what they call deep phenotyping, which is basically deep dive descriptions of the disease. And you can use a journal. There are apps out there now, I won't name them, there are lots of them, where you can take pictures, videos, show symptoms, have this repository of your child's disease process. And then we're all part of patient groups, social media, right? And finding another patient with the same variant is, that hallelujah moment sometimes. And it happens organically through these groups. And so joining these groups, talking with other families who are undiagnosed and sharing, maybe not your whole data set with them, but a genetic variant, talking about genetics reports, and you may find someone with the same variant. One of our patient navigators recently connected with someone whose child has the same variant as her son, and it had been classified a VUS. And so just through your connections, keep track of all the symptoms. I did not have an app. I had a 10-page Word document for my son's journey that was literally like, woke up, had a stuffy nose, walking kind of funny, called doctor. Just date after date. And it ultimately helped when they, were working on the disease, is to look at his progress and his symptoms and then compare it with other patients that they found. So that's work that you can be doing while you're waiting.
The other tools that I'll just comment on is Genome Connect can be very helpful. Again, it allows you to upload your genetic report, including variants of uncertain significance. Genome Connect will reclassify a variant and will let you know if it gets reclassified. And it's another way that you can put all phenotypic data in that connects with genetic data. Gene Matcher is a great resource for kind of the investigative community too, to try and find other people with a variant in the same gene that you might be interested in.
Absolutely. Those are all fantastic resources to use, and it's been exciting talking to more patients and caregivers today to hear about the value that they've found in connecting with people who have variants in the same gene, because I'm very much so in my research world and don't get to hear as many stories about these connections and how valuable they are, and then how you can then go to your clinicians, the researchers that you've connected with, and help them find these patients as well, which I think is such an asset to your community as well as the research community. But I'm sure many of us are excited to talk about research as well, and bridging from Genome Connect and thinking about how that plays into some of the projects that we're involved in. Dustin, I'll let you kick it off, as I know this is your real area. Sure.
Like I mentioned, I love genetics research. I'll shift gears and talk about the model organism side of things for a second. Just an overview here of, a pitch to say we can learn a lot from fruit flies, as I hope Michele will tell us a little bit more here in a second. But we can also learn a lot from C. elegans worms and from zebrafish and from yeast and from cells. It might sound strange, but it's really true. And I've learned a lot about that. Like I said, I'm privileged to participate in the Undiagnosed Diseases Network Model Organism Screening Center, where we do use worms and fish and flies to try to help families better understand what's going on with their child. We can sometimes take the precise human variant that we observe and engineer the model organism to have that same exact human variant. Or we can do something called humanization, where we can replace the model organism gene with the human gene. And so there's all the kinds of strategies, and then we can look and see, does it have an impact? So does this variant actually break the gene and cause a problem for the organism, or does it have no impact and it's fine? And that's not going to be a slam dunk definitive answer for the family, but it will provide evidence one way or the other. So yeah, I'll just pause there and say I'm a fan of model organism research, and the UDN, the patients and families who have participated in that research have really taught me so much through that process.
I still remember when the lead PI down in Houston called us to tell us that the fruit flies that they manipulated to have the same genetic variant as my son couldn't fly. And my husband was on the phone too, and he was like, oh my gosh, Mitchell can't fly either. And if you know my husband, it's totally his personality. But obviously, can't fly is a correlation to, walking and, neurologic deficit. So in addition to not flying, they also had an extremely reduced lifespan. And that was a huge, oh my gosh, we're pretty sure this is it. And then through Gene Matcher, they were able to find one other patient in South Korea, which then was our hallelujah moment. So yes, model organism work is fascinating to me. And just in case you're curious, because I learned that this recently, the worms are not like worms you see when you go fishing. They're tiny. And then the zebrafish are not like from Finding Nemo, the guy that was black and white with the scar on his face. Nope, don't look like that. They're also really, really tiny. So I just learned that this year. I do want to say just a little bit about the UDN, the Undiagnosed Diseases Network. It is currently an NIH-funded research study accepting applications. I'm happy to talk with anyone about questions about applying. Just a few key things to know about the research project. The patients that are typically accepted need to have quantitative findings. So abnormal MRIs, abnormal labs. It can't just be pain. We need some quantifiable data to go on. Previous genetic testing is also very good. The previous testing with the VUS, with quantifiable findings, having gone to multiple specialists who still don't know, that's the type of patient who we encourage to apply to the UDN. In order to apply, you do have to have a letter of referral from a provider, and you have to write a personal narrative. And that's where, keeping track of kind of your timeline and your history is helpful. So we have sites all over the country. Typically, we try to assign people to sites that are close to them, but it just kind of depends on where you live. But I'm happy to answer any questions offline about applying to the Undiagnosed Diseases Network. And I have another navigator with me here who also would be happy to talk with anyone.
Just wanted to mention a couple more things, if that's okay. Another resource I like to tell people about is a website called Model Matcher. So that's all one word, Google that, Model Matcher. That's patients and families can sign up for that and say, I have this variant in this gene and I would love to have a model. And then there's this behind the scenes connection that will happen to find out if there's any investigator that's also registered in that system to say, I have a model. And so it's a way to match those things up. The second note I want to make is a note of gratitude. First to all the patients and families who participated in research, but in particular to my friend Michele here. I can tell Michelle's a special lady, so was her son Mitchell. And it's just a real privilege to be on a panel here with her, sharing her stories. But it's also been a real privilege for me to be here today to hear your stories as well. This conference, I think you can all agree, is a pretty special event. It's particularly special for me, so thank you.
I certainly echo that sentiment. Even just in the few hours that I've been here today, I've had so many incredible conversations with some people that are in the room even, and it's really opened up my perspective, especially being in research and having a little bit fewer interactions with patients where I may actually get to connect with them, even on the level that I have in short conversations with some of you today. So I've really appreciated this opportunity and the opportunity to speak with you all as well, which, I don't want to cut us short. We still have plenty of time, and I have a few more questions before I'd love to hear from some of the questions in the audience. But something that I was thinking about as you all were speaking and kind of talking about your own experiences with research and having some successes with animal models and other forms of research that have eventually led to a diagnosis. Is that something that you feel with both the UDN, your work, I'm sure work that you've done as well, Chris, is that an outcome that you've experienced many times, or do you feel like Michele's case is a little bit more unique?
I think probably everyone in this room can also say that there's a journey, and from first discovery of a gene where there's not much known about it at all the way up to, we heard about tuberous sclerosis, and some of these genetic conditions have been known 20, 25 years now. There's a lot of data. There's a pipeline of drugs and therapeutics. It's been, slow, I'm sure, from a patient perspective. Fast in my career, 25 years to go from really none of my patients had a genetic diagnosis or extremely unusual, and now at least 40 or 50% do. They have, it's changed the landscape. Now people are finding their small groups, but what about the larger, larger umbrella organizations like the Epilepsy Foundation, CP? It has to be, I'm sure, confusing on a parent. Where do you go to for information at all different levels, because we've got this new, really powerful genetic tool.
And I probably need to be more clear when I tell my story. I am usually very exuberant about Mitchell's story because, we've seen so much amazing fruit come out of it. With him being patient number 1, first reported in 2020, and we now have 30 patients around the world that we have been connected with and have found. But I would say it is unique. I think historically the UDN has a success rate of diagnosing, I think, around 35%. And we'd love to see that increase, but that's still a large percentage that go through a very robust research program and come out without an answer. And it's, probably, as Dr. Gurnett said, we just don't know the answer yet. And, in a year, 5 years, 10 years, maybe the answer will be there. So, while I am excited and I love sharing the good news of our story, I do recognize that there are many, many of you out there still waiting, and that is very difficult.
Yeah, I agree. It's definitely a minority of cases. It's always just intellectually very exciting to find a new disease gene that just drives a lot of enthusiasm and brings a lot of people together to really kind of solve that problem and find that new gene. Let me just say that it requires a lot of things to go right for that to happen, right? So we have to find the right patient that has the right variant. We usually have to find the right second and third patient. We have to have the right model organism that has the right phenotype. But one of the ingredients I really want to highlight is it helps a lot if we know that there's an enthusiastic family that is motivated to participate in the research. It makes all the difference in the world to connect with a family that says, I would really like to know if this variant is causing my child's condition or not. And that can mean a lot to a researcher to keep driving the work. Because frankly, there's a lot of genes and a lot of variants. And if we hear from a family member that says, how about this one? That one gets moved to the front of the line and we focus on that one. So being a squeaky wheel in this environment is really a good idea.
Right.
And like I alluded to earlier, it just is like this virtuous cycle of encouragement on both sides, hopefully, right? That the investigators are encouraged by the patients, and hopefully the patients and families are encouraged to know that there's research going on as well.
And I do recognize, when you look at privilege, I had it all in this kind of story and trajectory. I worked at a world-class institution where if I had wanted, it would have been inappropriate, I could have knocked on Dr. Gurnett's door and been like, hey, come help me. And I had all this privilege, and we still had, a 7-year diagnostic odyssey. And at the UDNF, one of our things we're really working on is just breaking down barriers to access. I think about, the patients who don't speak English as a first language. I would be crying on the phone with insurance companies, and I had a master's in nursing and 18 years of experience. What about the families that don't have that? And so, the journey is different for everyone. We really want to break down those barriers so that it doesn't take, working down the hallway from an amazing researcher for your child to ultimately get a diagnosis.
Absolutely, yeah. I think there are so many barriers even to potentially getting a genetic test report that could have a VUS on it. And I appreciate you recognizing that, and recognizing, in addition to, having this diagnostic odyssey, which I'm sure was so incredibly challenging, that there was factors that led you to make that possible. I will finish up pretty soon, but could you speak just a little bit to resources that you're aware of that can, kind of help patients who may be less likely to have access to be able to access genetic testing, access testing, and make them aware of it? And I'm sure Drs. Gurnett and Baldridge can speak to this as well.
I mean, there are some free genetic testing that's available. The qualities vary, and depending on the disorder and the condition, there's research-based testing that can be available. Some places will, some companies are very good about working with co-pays and trying to get the cost down. But it's variable, it's a very changing landscape.
I'd say just the final resources to share is, we've talked a lot about just genetics, and as a patient or parent advocate, having a baseline knowledge is so important. And, I mentioned I went to nursing school, and really all I remembered was like the Punnett square, right, from high school. And there are a lot of really great resources out there. One is a lovely webinar that Global Genes put out, and it's Understanding Genetics. There's a really great Khan Academy, Intro to Mendelian Genetics, I believe it's called. And then the Child Neurology Foundation also did a really great webinar that you can find. So just get that basic understanding so that it's not as scary when you go to the geneticist, or when they're going to call a meeting to talk about results, and maybe you will feel even just a hair more comfortable at that meeting knowing a little bit of the lingo and what they're talking about.
Absolutely. And we feel that we can learn as much from patients, their caregivers, and advocacy groups as much, or probably more, than you can learn from us. So on that note, I would love to transition into hearing from people in the audience and hearing some of the questions that you might have for us.
Okay, perfect. Before that, let's give our panel a hand clap. Thank you so much. Questions?
Hi there. I am the Family Support Specialist for the Phelan-McDermid Syndrome Foundation. My son also has a Phelan-McDermid Syndrome diagnosis, so we work with Boston Children's and the natural history study and all of that. So thank you all so much for what you do. I often, well, not often, but often enough that it's worth a question, get families that come through with a VUS and uncertainty about where to turn. And we support families with a Phelan-McDermid syndrome diagnosis. It's very hard to send them away with nowhere to go. And so I'm wondering if you have any ideas of resources or organizations that I could suggest to folks who come through our membership with a VUS.
I love your question. This is a huge problem, like I alluded to earlier, and frankly, there are not enough resources for families that have VUS. Many research projects will simply only take families that have a definitive diagnosis, and that makes total sense to me, right? If we want to study a therapy, for example, we want to be sure that the patient has the condition before we test a therapy. I would encourage others, though, who are designing their research projects to consider including individuals with VUS as part of their natural history studies, for example, because then we can learn the natural history of an individual that has a VUS in that gene, and that VUS could very likely become a true disease variant or not over time, and then you would have the data. It would also serve as a nice comparator population, for example, within your natural history study. So I think there's a lot of advantages to including individuals with VUS. I know from talking with families that it is a delicate thing to say, am I part of this group? Am I not part of this group? And that's a challenge that unfortunately we're stuck with. That's why I think this is a big burden. The project we haven't mentioned at this table yet is the Brain Gene Registry that the three of us help participate in, and we have chosen to include individuals with variants of uncertain significance in that project for the reasons that I mentioned. Great question, thank you.
Perfect, thank you.
Hello. So for families that do receive a VUS diagnosis, but the disease has a biomarker, would a natural next step be testing for the biomarker to confirm?
Well, definitely for metabolic conditions where there's a laboratory test, absolutely a confirmatory test would be, but for most we don't have those. but absolutely, so it's definitely worth going to a geneticist who might have that knowledge.
Hi, hello again. My name is Izzy Duval. I'm with Cure HC, and my daughter also has a diagnosis of alternating hemiplegia of childhood. And something that we see in our disease group that I'm sure many others do as well is the phenotype-genotype correlation. And oftentimes we'll be able to say, yes, this one is more severe, but then there are often outliers, even like if we have a mutation that's almost always mild, but then we have two very severe patients with that exact genotype. I'm just curious if you could speak to why that might occur.
I think those are great opportunities for research, and I think the scientific community is just now starting to think that outliers are a really great place to look for modifiers, and that may point to therapeutics for the future. So if you are in that situation, keep being the person that asks, why is my child not like all the other, and hopefully there'll be research opportunities that can help. Really, you might be able to really help the field move forward. It's telling us something.
Completely agree, and I'll just add, obviously genetics is complicated, and I wish that it was always a simple answer with a single variant causing a single gene, and frankly that's like the mental model that I carry around with me all day. But then I am faced with these interesting situations where, wait a minute, I thought this was a pathogenic variant, but now I'm staring at an individual who has that pathogenic variant that has no symptoms whatsoever. What? And we're learning more and more that that's really the case. And genetics is littered with examples of historical bias, where the first publications are the most severe individuals with variants in that gene. And then over time, as we sequence more and more people, we learn that actually, the spectrum is much more broad, and that there are more mildly affected individuals. So I think what Dr. Gurnett was referring to is there might be a second gene involved and a variant somewhere else in the genome that might be impacting, so gene by gene interactions. We also know that the environment is important, the in utero environment, the ex utero environment, et cetera. There's all kinds of complicating factors that in my research I frankly ignore because it's just too complicated. But we really need more work in those areas to uncover these different relationships that are frankly very, very complex.
Okay.
Hi, my name is Annalise, and I'm a patient advocate. And I had a question. You had mentioned VUS classification with parents, and I'm adopted, but I have an identical twin sister. Does that impact VUS classification? Because previously we had assumed if she has a VUS, it's not worth paying the costs to get that panel, but I'm curious now if that could impact any of the research and down the line and reclassification process.
Take a chance. Start with it.
At least from my perspective, I think that is absolutely worthwhile. I think there's a lot of twin studies that we often hear about that are really, really revealing, because there's not many times where somebody shares your genetics, shares your prenatal environment. And, if we also see, kind of going back to the idea that there is a lot of variability with genetics, there can be twins who have the same genetic change and present completely differently, which I'd like to say I have an understanding of, but I really don't. Even a condition that I have gained some expertise in, there's a case exactly like this where there are identical twins with very different presentations, and they have the exact same variant, and there are likely other factors that are involved. And there also may be, we've started to look into the idea of clinical present or subclinical presentations, where unless you really do a lot of investigating, a lot of assessments, you might miss them. And going back to the brain gene registry, that's something that we actually look at if we see that, for example, a parent has passed on a variant or a sibling shares a variant with an individual who might have a more typical presentation. Maybe if we do some testing, we can find that they have more in common that we might just see on the surface.
Completely agree. I'll just add too, a factor we haven't talked about yet too much, I think, is this idea of mosaicism. Actually, we all think we have one genome in our body, but we probably have or collect amalgamations of multiple genomes, and oftentimes we only test the blood or a cheek swab when we do our genetic testing, and we're not actually testing the brain or the organ that's particularly involved. So I'm not at all saying that that's what's happening in this particular situation, but I have seen circumstances where there are supposed identical twins where the genotype is actually different between the identical twins, and the presumption for that is that there was a mosaic change that happened in one of the twins but not the other. So there are weird genetic things that happen all the time that are fascinating, but they also make a difference clinically for families.
Okay, awesome. One last question. This is why I didn't take genetics in college.
Hi, my name is Ashley, and I work for the Association of Public Health Laboratories with newborn screening programs. So as you can imagine, whole genome sequencing and exome sequencing is expanding and looking into newborns, which means we find a lot of VUSs. And so I was curious on your guys' take on reporting those back to patients in the situations where they don't have symptoms. They didn't necessarily ask for the test. It was mandated. Feels kind of wrong, like knowledge is power, to not give it to them, but at the same point, newborn screening is normally like a very actionable thing. So that's part one of it. And then part two is, what's the responsibility of a public health program then to continue to reevaluate these? Obviously, they're going to keep growing and they change. And so I think programs struggle with that of like, where does that responsibility lie?
There's a lot of gray zone in genetics, and I think we certainly don't want to be retaining information that belongs to a patient, and yet you really want to be sensitive that the child's not 18, so they're really not able to consent for receiving something that may not impact them for years to come. I think a lot of clinicians and probably public health are pretty conservative in what they report. So if there is a VUS, more likely than not, people are probably not reporting them, but every case would be different.
Completely agree. Every case is different. Every gene is different. We have some preliminary data suggesting that things that fall in the VUS bucket, more than 90% of them will end up benign, and less than 10% will end up being pathogenic. So that's one consideration. The other is like the indication for testing. These are healthy newborns, presumably, and so we're not searching for a diagnostic odyssey. We're not searching for an answer for a particular medical condition. I think I love that you asked this question in the last 2 minutes, because it would be great to have a 20-minute conversation about the ethical considerations of newborn screening, of which I am not an expert. I agree. I guess if I were to have an ideal state, I might suggest these variants might have a special place to live. If they could even go in the ClinVar database potentially. Yeah, great. And so then there's the opportunity for reclassification. Someone, I don't know if it's the public health service, but someone should be able to link back that variant to the individual so that they can get the information back. Yeah. But I mean, frankly, I might turn it back around to you and say you're in a better situation to decide how best to handle these. But that's my 2 cents. Yeah.
Okay, Abigail, I'll pass it back to you.
Well, thank you all so much for all of your fantastic questions. It was wonderful to hear from you, and hopefully some of my questions for the panel were questions that you all had as well. I would encourage you to, if you're in a position where you may have a VUS, know people that have VUS, to engage with some of the resources that have been discussed today, and I would also welcome you to chat with us. I'll at least be around for the rest of the conference. I know you two have to head out at the end of the day, but would be happy to chat with anybody as well. So thank you all so much.